All right, here we are with this is a compass. Just all it does is hold the pencil a certain distance away from you got a pivot point, the center of the circle. Okay, and the straight edge. I just use this straight edge. I don't have to use any measurement. Don't need a calculator right now. Okay, so all I did here was, you might remember this back in school. I hope you got to do this a little bit. Just, you do one circle in the center, and then you keep the same measurement here, and you go around the outside, do 6 more circles. It just turns out to work out perfectly that way. And then we're going to use our straight edge real quick and connect from the center of the circle to the circumference, and then the flip side of this. Okay, there's our rhombus that I was just showing that I had painted in black in the last little video. Okay, it's the same shape, different size. If I break this, if I strike a line from one vertex to the opposite over here and do it again, you can think about why this is true with congruent triangles and all. But there I have 4 congruent triangles that make up this rhombus, and every rhombus, if you strike a line from the opposite vertex, cut it in half this way, cut it in half this way, you have four right triangles that are all identical, all congruent triangles. So then I have a right triangle, so I got leg, hypotenuse. So if I have the measure of one side and the hypotenuse, I can get the other leg. Or if I have both legs, I can get the side of the hypotenuse, okay? And with this rhombus, of course, there's some very interesting specific formulas for finding out the length of the diagonals, knowing this and that. And you got to know some of the angles. Anyways, we're going to concentrate on the Pythagorean theorem. Just going to do this other one real quick here. How did I get that other one? How did I construct that other one? Well, I have the one that I was going to do. If I connected here to here, I would have the same one I just showed you. So I realized that the one from the LAS building has angle that's half that measure. If you just look at it and you start thinking about it, you'll figure out. So how did I make that one? Well, cut this angle in half. So then if I, where'd my little straight edge go? There it is. If I connect this right here, and now I know that this length is the same as this, right? Because I used an arc to do it. And then I'll just have to flip that over here. I'd have to flip this, have this isosceles triangle here. If I made an isosceles triangle, well, let me go ahead and do that, because then we'll look at this little right triangles. There's a little isosceles triangle. If I could flip that over this base, then I would have it, right? I would have the rhombus that I'm looking for. Well, how do I do that? Well, I got my handy dandy protractor, and I got it at this length, right? And I want that same length. I want this other side to be that same length, and I want this side to be that same length. Oops. So then we find where it has to intersect in order to have. That didn't come out. Oh, I bent the leg of it. You gotta be careful of your device. Let me check one more time. Something didn't change. Oh, it did. That's how I messed up. The leg was bent on it. Okay, I got it right there. Yeah, you always make mistakes doing these. So I go, once again, I got that correct now, that length correct. Go from this side. It's of course drawing the circle because it's from the center, and then I go over to this one. It'll be a little bit different. It'll find where that intersection point is. Then I connect that, and I have that other rhombus. Okay. And just like that the rhombus with the So this one has half, same length sides, but the angle here, this angle is 30 degrees. This is 30 and this is 150 here. Whereas that other one, this other rhombus that's over here, is a 60 degrees here and 120 here. So I got this rhombus, and I could break it into congruent right triangles. Okay, and then these are right triangles. All right, Pythagoras theorem. All right, well, I'll do the specific problems we're doing today.